وصلنا. Sketch up where we left. We're in unit 2. 2. Creating a histogram. Okay.
So let's say you were to go to a restaurant, and just out of curiosity, you want to see what the makeup of the ages at the restaurant are. So you go around the restaurant and you write down everyone's age. And so these are the ages of everyone in the restaurant at that moment. And so you're interested in somehow presenting this, somehow visualizing the distribution of the ages, because you want to just say, well, are there more young people? Are there more teenagers? Are there more middle-aged people? Are there more seniors here? And so when you just look at these numbers, it really doesn't give you a good sense of it. It's just a bunch of numbers. And so how could you do that? Well, one way to think about it is to put these ages into different buckets, and then to think about how many people are there in each of those buckets, or sometimes someone might say how many in each of those bins. So let's do that. So let's do buckets or categories. So I like, sometimes it's called a bin. So the bucket, I like to think of it more of as a bucket. The bucket, and then the number in the bucket. The number in the bucket. Number, I'll just write the number. Whoops. It's the number. It's the number in the bucket. All right. So let's just make buckets. Let's make them 10-year ranges. So let's say the first one is ages 0 to 9. So how many people, let me just define all of the buckets here. So the next one is ages 10 to 19, then 20 to 29, then 30 to 39, and 40 to 49, 50 to 59. Make sure you can read that properly. And then you have 60 to 69. And I think that covers everyone. I don't see anyone 70 years old or older here. So then how many people fall into the 0 to 9-year-old bucket? Well, it's going to be 1, 2, 3, 4, 5, 6 people fall into that bucket. How many people fall into the 10 to 19-year-old bucket? Well, let's see. 1, 2, 3. 3 people. And I think you see where this is going. What about 20 to 29? So it's 1, 2, 3, 4, 5 people. 5 people fall into that bucket. All right. What about 30 to 39? We have 1, and that's it. Only one person in that 30 to 39 bin or bucket or category. All right. What about 40 to 49? We have 1, 2 people. 2 people are in that bucket. And then 50 to 59. So you have 1, 2 people. 2 people. And then finally, ages 60 to 69. Let me do a different color. 60 to 69. There is 1 person right over there. So this is one way of thinking about how the ages are distributed. But let's actually make a visualization of this. And the visualization that we're going to create, this is called a histogram. Histogram. We're taking data that can take on a whole bunch of different values. We're putting them into categories. Then we're going to plot how many folks are in each category. How big are each of those categories? And actually, I wrote histogram. I wrote histograph. I should have written histogram. So a histogram. So let's do this. All right. So on this axis, let's see. The largest category has 6. So this is the number of folks. And it's going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is the number. And on this axis, I'm going to make the buckets. The buckets. And let me scroll up a little bit now that I have my data here. I don't have to look at my data set again. So I have 1 bucket. This is going to be the 0 to 9 bucket right over here. 0 to 9. Then I'm going to have the 3. Actually, let me just plot them since I have my pen that color. So in 0 to 9, there are 6 people. 0 to 9, there are 6 people. So I'll just plot it like that. And then we have the 10 to 19. There are 3 people. So 10 to 19, there are 3 people. So I'll do a bar like this. Then 20 to 29, I have 5 people. 20 to 29, which is going to be this one, which is getting, I'm writing too big. So 20 to 29, this is going to be this bar. There's 5 people. 5 people there. So it'll look like this. I should have made the bars wide enough so I could write below them, but that train has already left. All right. All right, then 30 to 39, I'll try to write smaller. 30 to 39, that's going to be this bar right over here. We have 1 person. 1 person. And then we have 40 to 49. We have 2 people. 40 to 49, 2 people. So it looks like this. 40 to 49, 2 people. Almost there. 50 to 59, we have 2 people. 50 to 59, we also have 2 people. So that's that right over there, this category. And then finally, 60 to 69, we have 1 person. 60 to 69, we have 1 person. We have 1 person. And what I have just constructed, I took our data, I put it into buckets that are kind of representative of the categories I care about. 0 to 9 is kind of young kids. 10 to 19, I guess you could call them adolescents or roughly teenagers, although obviously if you're 10, you're not quite a teenager yet. And then all the different age groups. And then when I counted the number in each bucket and I plotted it, now I can visually get a sense of how are the ages distributed in this restaurant. This must be some type of a restaurant that gives away toys or something, because there's a lot of younger people. Maybe it's very family friendly. So every adult that comes in, maybe there's a lot of young adults with kids or maybe grandparents up here, and they just bring a lot of kids to this restaurant. So it gives you a view of what's going on here. Just a lot of kids here, a lot fewer senior citizens. So once again, this is just a way of visualizing things. We took a lot of data that can take multiple data points. Instead of plotting each data point like we might do in a dot plot, instead of saying how many 1-year-olds are there, well, there's only 1 1-year-old. How many 3-year-olds are there? There's only 1 3-year-old. That wouldn't give us much information. We would just have like these single dots if we were doing a dot plot. But as a histogram, we're able to put them into buckets. And we're just like, hey, generally between ages 0 and 9, we have 6 people. And so you see that plotted out just like that. And obviously this doesn't apply just to ages of people in a restaurant. It applies to all sorts of data that you might want to collect and observe.
Okay.
In this video, we're going to talk about another way of visualizing data called the histogram. Histogram, which is a very fancy word for a not so fancy thing. And I think it's probably fair to say that the histogram is the most used way of representing statistical data. And let me just show you how to figure out a histogram for some data, and I think you're going to get the point pretty easily. So I have some data here, and I want to represent it with a histogram. And what we're going to see is how frequent are each of these numbers. And in order to figure that out, let me just write the numbers down, and let me just categorize them in their respective buckets. So I have a 1 here. So I have 1, 1 right there. I have a 4. Let me put, so I want to leave space for the 2, the 3, and put a 4 there. I have a 2. That 2. I have a 1. Let me put that 1 on a stack right above that 1. I have a 0. Let me put the 0 to the left of the 1. I want to put them in order. I have a 2. Another 2. Let me stack that above my first 2. I have another 1. Let me stack that above my other 2 1s. I have another 0. Let me stack it there. I have another 1. Another 1 right there. Then I have another 2. Another 2. Another 1. Another 1. I have 2 more zeros. 0, 0. I have 2 more 2s. 2 more 2s. I have a 3. I have a 3. I have 2 more 1s. 2 more 1s, another 3, and then I have a 6. So no 5s, and then I have a 6. And that space right there was unnecessary. But right here, I've just rewritten these numbers, and I've essentially categorized them. Now what I want to do is calculate how many of each of these numbers we have. So let me go down here. So I want to look at the frequency of each of these numbers. the frequency of each of these numbers. So I have 1, 2, 3, 4 zeros. I have 1, 2, 3, 4, 5, 6, 7 ones. I have 1, 2, 3, 4, 5 twos. I have 1, 2, threes. I have 1, 4, and 6, and sorry, and 1, 6. So we could write it this way. We could write the number, and then we can have the frequency. The frequency. And so I have the numbers 0, 1, 2, 3, 4. We can even throw 5 in there, although 5 has a frequency of 0. And we have a 6. So the 0 showed up 4 times in this data set. 1 showed up 7 times in this data set. 2 showed up 5 times. 2 showed up 5 times. 3 showed up 2 times. 4 showed up 1 time, 5 didn't show up, and 6 showed up 1 time. So all I did is I counted this data set. I mean, I did this first, but you could say, how many times do I see a 0? I see it 1, 2, 3, 4 times. How many times do I see a 1? 1, 2, 3, 4, 5, 6, 7 times. That's what we mean by frequency. Now, a histogram is really just a plot, a kind of a bar graph, plotting the frequency of each of these numbers. It's going to look a lot like this original thing that I drew. So let me draw some axes here. So the different buckets here are the numbers. And that worked out because we're dealing with very clean integers that tend to repeat. If you're dealing with things that are more, that aren't just, that the exact number doesn't repeat, oftentimes people will put the numbers into buckets or ranges. But here they fit into nice little buckets. So you have the numbers 0, 1, 2, 3, 4, 5, and 6. This is the actual numbers. And then on the vertical axis, we're going to plot the frequency. We're going to plot the frequency. So 1, 2, 3, 4, 5, 6, 7. So that's 7, 6, 5, 4, 3, 2, 1. So 0 shows up 4 times. So we'll draw a little bar graph here. 0 shows up 4 times. Draw it just like that. 0 shows up 4 times. That is that information right there. 1 shows up 7 times. 1 shows up 7 times. So I'll do a little bar graph. 1 shows up 7 times. Just like that. 1 shows, I want to make it a little bit straighter than that. 1 shows up 7 times. 1 shows up 7 times. 2, I'll do it in a different color. 2 shows up 5 times. 2 shows up 5 times. Do a bar graph, go all the way up to 5. 2 shows up 5 times. 3 shows up 2 times. 3 shows up, doesn't even, a histogram. This right here is a histogram. Very fancy word, but I think you'll agree it's a fairly simple idea.
Let's say that you have a cherry pie store, and you've noticed that there is variability in the number of cherries on each pie that you sell. Some pies might have over 100 cherries, while other pies might have fewer than 50 cherries. So what you're curious about is, what is the distribution? How many of the different types of pies do you have? How many pies do you have that have a lot of cherries? How many pies do you have that have very few cherries? How many pies are in between? And so to do that, you set up a histogram. What you do is you take each pie in your store. Let me see if I can draw a pie of some kind. It's a cherry pie. I don't know if this is an adequate drawing of a pie. But you take each of the pies in your store, and you count the number of cherries on it. So this pie right over here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you keep counting, and let's say it has 32 cherries. And you do that for every pie. And then you created buckets, because you don't want to create just a graph of how many have exactly 32. You just want to get a general sense of things. So you create buckets of 30. You say, how many pies have between 0 and 29 cherries? How many pies have between 30 and 59, including 30 and 59? How many pies have at least 60 and at most 89 cherries? How many pies have at least 90 and at most 119? And then how many pies have at least 120 and at most 149? And you know that you don't have any pies that have more than 149 cherries. So this should account for everything. And then you count them. So for example, you say, okay, 5 pies have 30 to 59 cherries. And so we create a histogram, or you create a histogram, and you make this magenta bar go up to 5. So that's how you would construct this histogram. That's what this pies at different cherry levels histogram is telling us. So now that we know how to construct it, let's see if we can interpret it based on the information given in the histogram. So the first question is, based on just this information, can you figure out the total number of pies in your store, assuming that they're all accounted for by this histogram? And I encourage you to pause the video and try to figure it out on your own. Well, what's the total number of pies? Well, let's see. There's 5 pies. There's 5 pies that have more than, or 30 or more, have at least 30 cherries, but no more than 59. You have 8 pies in this blue bucket. You have 4 pies in this green bucket. And then you have, what is this? This is 3 pies that have at least 120, but no more than 149 cherries. And this accounts for all of the pies. So the total number of pies you have at this store are 5 plus 8 plus 4 plus 3, which is what? 5 plus 8 is 13, plus 4 is 17, plus 3 is 20. So there are 20 pies in this store. But then you can ask a more nuanced question. What if you wanted to know the number of pies with more than 60 cherries? The number of pies with more than 60. So number of pies with, let's say 60 or more. 60 or more. 60 or more cherries. So let's think about it. Well, this magenta bar doesn't apply because these all have less than 60. But all of these other bars are counting pies that have 60 or more cherries. This is 60 to 89. This is 90 to 119. This is 120 to 149. So it's going to be these 8 cherries that are, these 8 pies that are in this bucket, plus these 4 pies, plus these 3 pies. So it is going to be essentially everything but this first bucket. Everything but all the pies except for these 5 pies have 60 or more cherries. So it should be 5 less than 20. And so let's see, 8 plus 4 is 12, plus 3 is 15, which is 5 less than 20. So using this histogram, we can answer a really interesting question. We can say, well, wait, how many more pies do we have that have 60 to 89 cherries than 120 to 149 cherries? Well, we say, well, we have 8 pies that have 60 to 89.
Yeah, let's do this. I'm ready to practice. Following data points represent the number of guests at Hunter's Barbecue House each day since they opened. In 96. The data create histogram to release histogram, and each bin excludes the left end and includes the right end. Each bin excludes the left endpoint and includes the right endpoint. What do you mean? And from 0 to 100. So each bin excludes the left endpoint and includes the right endpoint. So we got 96, 0 to 100, 0 to 100. How many? 1, 2, got 2, and then 100 to 100, 200, which bin excludes the left endpoint, excludes the left endpoint, includes the right endpoint. So from 0 to 200, from 100 to 200 to 200. So I got 0, and from 200 to 300, 1, 2, 3, 4, 1, 2, 3, 5, 6. This is what it gets confusing. Each pin excludes the left endpoint. Exclude this one. It includes and includes the right endpoint. I'd go with this slot sheet. Okay. The following data points represents how many tunnels carry the groundhog dog each year. Dog each year. Using this data create as the ground from 0, this number of years, get number of years, number of tunnels. So each year, number of tunnels. So each year, 18, the points represents how many tunnels carry the groundhog dug each year. 13, 5, 13, 9, 6, 2, 10. 1, 2, 3, 4, 6, 7. So 18, 5, 'I don't get the number of years. 13, 9, 'Is not gonna cut it. Got 6. Okay. So this is not gonna get. From 0 to 4. 2. 2. 1. Okay, from 4 to 8. 4 to 8. 5. 6. 2. 2. From 8 to 12. 8 to 12. 9. 10. 2. 2. From 12 to 16. 12 to 16. 13. 13. And then we got from 16 to 20. 1. How many years? I got 2, 4, 4 plus 3, 7. 1, 2, 3, 4, 5, 6, 7. Below is the number of pages in each 6 books that Pedro read this summer. Data create number of books. Books, number of pages. The number of pages in each of the 6 books and Pedro. Okay. So it says from 0 to 150. I got 44. So 1. From 150 to 300. I got 255. 2, 1, 2. From 300 to 450. 300 to 450. 3. From 150 to 300. 2, 1. 255. Okay. From 300 to 452. And 584, 1. That's 4 plus 2, 7. Plus 2, that's 6. The following data points represent how many tunnels Gary dug each year. So 0 to 4, get 1. Just did this. What do you mean? 4 to 8, got 6, 5, 6, 5, 2. From 8 to 12, 8 to 12, got 9, 12 to 16, wait, 8 to 12, got 9 and 10, 9 and 10, so this is 2, and from 12 to 16, got 13, 1, I got 4, 3, 7, 6. Exercise, read the histogram. Okay. How many cherry pies have 90 or more cherries? So I got from here to here, this 4 and 3, 7. 7. Okay. How many pumpkins are in Leonard's patch? Mass pumpkins. Pumpkins are in Leonard's patch. Number of pumpkins. I got 4, 5, 9, and I got 8, 17, and I got 6, that's 23, and I got 2, it's 25. Okay, how many more hostel rooms have 4 to 7 guests than 20 to 23 guests? How more hostel rooms have 4 to 7 guests than 20 to 23? So we have number of guests 20 and 23. We have it at 1, only 1 hostel room. Then we got 4 to 7 has got 5. So I got 5, 4. Okay, how many hostel rooms have 11 or fewer guests? Number of hostel rooms 11 or so 11. So from here I got 8, 5 plus 13, I got 3, 16. 16 I said, not 15. Okay, how many vehicles are at Nam's gas station? Gas station. Which vehicle? How many vehicles at Nam's gas station? Number of vehicles. We got 3, 7, and wait, this is 3, 7, 4, and 4, 7, and 5, that's 12, and 6, it's 18, and 3, that's 21. Wait, this is 3, and this is 2. Wait, okay, 2, 3, 5, 5, and 6, 11, 11, and 7 are 18, 18 and 4 is 22, and 3, 25. 25 vehicles. God damn it, I got 3 and 4, 7, and 5, that's 12, and 6, that's 12, and 5, and wait, and 7, and 6, 12 and 6, 18, and I got here 3, that's 19, and I got here 2, 21. 21. Number of vehicles, I got 3, 4, 7, 7 and 5, 12, 12 and 6, 18, and then I got 16 and 3, that's 19, and I got 19 and 2, that's 21. What do you mean it's not 21? Number of vehicles. Three, 7. God damn it. 3 plus 4 plus 5 plus 6 plus 3 plus 2, 23. God damn it. 23. Next article. So histogram review. Histogram displays numerical data by grouping data into bins of equal width, and each reading histogram the bars and creating below the meters. It's allowed to make a from 0. Okay, the number of what is it? Okay. So that's it. Where are we? Instagram review. Unit 2. And there, so that's it for today's statistics and probability. Go back to our statistics and we got them. Unit 1. So we got them all. Here. Okay, that's it for today's statistics and probability. See ya.